Facilitated diffusion is movement down a concentration gradient from an area of high concentration to an area of low concentration. But facilitated diffusion requires a protein to cross the plasma membrane. Water and other polar molecules are not able to cross this area of the lipid bilayer because that's the area that is hydrophobic, and polar molecules get repelled by the hydrophobic region because that region is created by the nonpolar tails of the phospholipids. Therefore, a transport protein acts like a bridge spanning the lipid bilayer and covering that hydrophobic region. So now polar molecules are free to move down their concentration gradient using the protein to cross the membrane. Water crosses into and out of the cell membrane using a protein called an aquaporin. And let's just pretend that this is an aquaporin, and these are little H2O molecules. When you drink a diuretic like coffee or alcohol, aquaporins are removed from the urine generating tubules in your kidneys, and you are incapable of conserving that water. This is commonly known as, quote, breaking the seal, which is an undeniable urge to urinate. Yes. Also, the urine will be incredibly dilute because you were unable to conserve it due to the lack of these aquaporins. Most molecules that use facilitated diffusion are polar molecules or polar ions, like sodium and potassium cations, water, of course, and glucose. There are different types of protein carriers that complete facilitated diffusion for polar molecules. One kind is a channel that is always open. We call those leak channels, and you can see one of those here on the left in purple. This channel is open for travel. However, channels they're not a free-for-all. Channels have specific shapes that allow one item to move through them. So potassium can't move through the sodium channel, and sodium can't move through a potassium channel. There are other proteins that are embedded in a cell membrane that also complete facilitated diffusion, but these proteins are called carriers. The term carrier indicates that this protein must change its shape for the molecule to pass down its gradient. But this is still a passive process requiring no energy. Carriers usually have a limit to how many items they can carry across in one shape change. In this diagram on this slide, you can see a carrier on the right in green. Notice how the carrier is open on one end, which is the cytosol end, and that it's loading up molecules from inside the cell. Yes. Just as you try very hard to carry at the same time all of the items from the fridge that make a great sandwich, this carrier protein also loads up before it does its shape change and releases all of those molecules to the outside of the cell. I somewhat hate this term, conformational. So now everybody who is listening, raise your hand if you know what this word means. Okay, yeah, just as I thought, no one raised their hand. No, I'm kidding. So, wait, I just have to take the opportunity here to remind you of the glossary of your book, which is actually, this word is not contained in your glossary. I just don't want you to forget about the glossary of the dictionary, right? Because it is a great resource. I dislike this term because it's a term that I've seen probably in every textbook that I've had. Authors use it, I guess, under the assumption that students know what this word means. But I don't think that's true. Oftentimes you come to this class not knowing what this word means. This word, conformational, it just means shape. So when we say conformational change, it's a fancy way of saying shape change. So channels don't change their shape. They're just open pores in the cell. And if you can fit, you get to go through. Carriers have specific shapes, but they also have to change that shape in order to bring a molecule across the cell membrane. Carriers are still using the gradient, right? They're still using a gradient to move the molecule across the cell membrane. But take a look at these two molecules here. Their shape is different, and it's that conformational change that allows it to move the molecules across the cell membrane.